Hey everyone, today I'm going to be building a Flappy Bird clone and I wanted to take you along for the ride. So, no sense wasting time, let's jump on in. Alright, so the first thing I'm going to do today is get a Unity project built, or create a new Unity 2D project. So I'm going to create the 2D template here, and going to call this Flappy Bird clone. Alright, so I've created a project there. And while that is building, it'll take it a few minutes. I'm going to go ahead and open up GitHub and switch over to the InsoCode account here and create a new repository for this project. That's opening, so I call this Flappy Bird clone. Make it a public repo. That is just perfectly fine. So now we have a place to store our data at, our project files anyway. And while that is still running, I'm going to go ahead and pull up the gitignore for Unity. GitHub provides a template for a gitignore file to use with Unity, and basically that just ignores all of the projects that are generated while running Unity and preventing those from getting put into the GitHub repo or the Git repo. Raw view of that. And it takes a few minutes for the project to get initially created, so apologies on that. Not really anything can do about that. Not a lot to do while waiting for some of this stuff to go. It takes it a minute. Almost there. There we go. All right. So now with the Unity project created, we can go ahead and open up a terminal window. Let's see if we can't get to our Flappy Bird clone folder and initialize a Git repository. You can see it's got our stuff in there. I'm going to go ahead and open this directory in VS Code. It's just an easy text editor we can view the whole project with and create the gitignore file, and go ahead and copy and paste that template. So now when we come back over here and we do git status, you can see, oh, it's not selected all of these extra folders that aren't needed. So with that, I'll go ahead and create an initial project commit, or actually I need to add all of these files and then I can make that. Okay, now with that in place, I can come back over here and add our GitHub repo as a remote source, so we can push this up and have a backup of our code offsite. Or actually main. All right, now we are on the main branch, and we should be able to refresh this and see our project files there. Great. So we can close out of these windows and go back to our Unity project. Now, the first thing I tend to like to do is get the Unity environment set up. So I'll go ahead and change this to a 2x3 view, which gives us a nice view of the scene editor as well as the game preview window, the hierarchy, the files in our project, and a good chunk of space to the inspector. So the next thing that I want to do is come over here to the project settings, and in the editor I want to go ahead and give a root namespace and coding. All right, that way our files, our C# scripts won't have name collisions with anything else. I don't think any of our names are common names that we'll be using in this project, but it's kind of a good habit to get into. Okay, so with that done, the next thing we're going to do is actually create a new scene called, save this as gameplay. This is where our gameplay view is going to live, pretty much our entire game. So with that, we don't need the sample scene anymore, so we can delete that. And then one last thing we need to do is make sure that when we build and run this, that our new gameplay scene is included. So we're going to delete the sample scene there and drag the gameplay scene in. And that should be good. All right, so now the next thing that we're going to do is, for Flappy Bird, it's actually a mobile game. So I want to give this the feel of a mobile game, which is often in not the 16:9 aspect ratio that most desktop monitors are, but rather a vertical 9:16 aspect. So I'm going to change the aspect ratio to that, so I'm always aware of my boundaries on the scene. That should be good for this section here. So now that I've created the scene, just want to go ahead and come over here to Flappy Bird. Now you can see in my main folder here, and I've got some files. So add all of this stuff and added 9:16 aspect ratio in placing. And I'll go ahead and push that up. Okay. So now the next thing that we're going to need is our assets, our graphical assets for this game. So I'll go ahead and create a folder for sprites. And come over to the assets that I've already previously downloaded and drag the Flappy Bird sprite assets into the scene. So now that I've got that in my project, I need to actually change some settings on the sprite sheet so that it'll work properly in our game. The first is, this was built for a 16:16 pixels tile size. So we want to set that. The filter mode here should be point, and this will help it. Just a moment here. All right, sorry about that. One of my dogs had to go outside. Okay, so we want to set the filter mode to point so that we have nice clear images. The sprite sheet itself is 512 by 512, so we want to change the max size here to 512, and I'll just have it use less space. And the compression we want to set to none, no compression. So with that set, we want to come over to the Sprite Editor, and we want to divvy up our sprite because it's right now it's just one great big square. So what we're gonna do is change the single sprite to a multiple sprite, apply that, and now it's going to let us slice up this image into multiple sprites. And as we can see, the sprites are actually not all uniform in size. So some of the ways of splitting it up just don't make sense. So grid by cell size wouldn't work because, well, there's not a specific size that any one thing sticks to. By count, same type of deal. There's not the same number of things in each column. So I want to go ahead and use the automatic setting and let it slice on its own. You can see it's done a pretty good job here of outlining each of the different parts of the sprite sheet. There are a couple here that don't look 100% correct. So for example, the get ready and the game over, I would actually want those to be just one continuous sprite. So I'm going to go ahead and delete that and then bring over this to the edge there. That should be good. And then get rid of this one and bring this edge over here. Okay, I think that is good. The rest of them, this one right here. Yeah, these guys should be part of all one. Take this and drag it out. I don't think we're actually going to use this particular one, but good to go ahead and take care of all of the different elements here. So okay, sprite sheet is divvied up pretty well now, so I'm going to go ahead and hit apply. So now instead of one sprite, we have all of these different assets that we can then use in our scene. Pretty neat. All right, so now the next thing that we're going to tackle is the background, and we've got two different backgrounds here to choose from. I'm going to pick this daytime one and drag it onto the scene. I'm going to rename this to background. And we see that this sprite has a sprite renderer component on it already, and it's pointed at this particular sprite. The camera on this image, you can see the camera, if we outline it here, is actually not showing the whole image. So we want to scale up our camera a little bit, and we're going to do that by, we can see actually in our units here, that's 1, 2, 3, 4, 5, 6, 7, 8 units tall on the y-axis. So that's what we want to put in here. We want to put in 8. Now the camera size has perfectly fit our background image. That's great. The next thing that we want to do is add some scrolling effect to this background. Right now it's stationary. If we play the game, it just does its own thing. But what we would like it to do is to actually scroll to give the impression that there is the background is continuously moving. However, as you can see, when we move this image off to the side, there's nothing there. What we would like to do is give some kind of wraparound effect so that when the image starts to go off the side of the screen, the part that's gone off the side of the screen shows up over here and just keeps repeating endlessly. So how could we go about doing that? Let's go ahead and do that via a script. So let's create a scripts folder here. Create a new script, and we'll call this the horizontal background scroll. We will attach this to the background script, or the background sprite. All right, with that in place, you can go ahead and open up this script. It's going to open the JetBrains Writer IDE and load up this script file. And the first thing I will do is go ahead and get rid of some of this default stuff in here. We've got our class inside of our namespace, and the class itself derives from the mono behavior. So, okay, what do we want to do with this script? Well, what we want to do is actually cache where this, or ideally what we want to do is take the image that we're using for a background. If it fills up the whole background, what we end up wanting to do is tile the background and double its width, and then as we scroll across and the background gets to the end here, we want to change the image from being at, you can see it's at negative 4.5, 0 is where the camera reaches the end of it. We want to instead set it back to where it starts. So the image position right here. And it will give the effect of, if we do that continuously, of having the background scroll. So you can see down at the bottom, the background scrolling, 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 scrolling. If it got to this part and just immediately changed the position of this image to right here, then it could continue scrolling and scrolling and scrolling, and the edges would match up. So let's move this back to default. Change this back to the way that it was. Oh, we want this to be 9. Simple, and change this back to there. So the thing is though, we can actually have our script do all of this for us. So we don't have to do anything to get a scrolling background other than drop a background image onto the scene, put our script on it, and give it a scrolling speed, and then it'll just work. That's the goal of this. So let's see how we could do that. We've already identified, first we'll need to make the image bigger, but we can do that programmatically. We can actually change these values right here like we did in the editor via a script. So we need a few things in order to do that. The first thing that we're going to need is some sort of start position for the texture. So I want to create a private variable, vector 3, start position. Or actually, what I want to do is create a start method, and inside the start method, I want to take I need a reference to the sprite, and I need to set the current position of the sprite. So let's go ahead and create a private sprite renderer. Actually, we don't need to. We're not actually going to use this anywhere else, so we'll just go ahead and grab the sprite renderer here. Get component, sprite renderer. Okay, now what we want to do is enable the tile mode on the sprite renderer. Tile mode equals, or the draw mode equals tile. Okay. The next thing we want to do is actually change the width of this sprite renderer to be the 3 times the size of the image. If we do that, let's take a look back here real quick. We change this to 3 times 9 is 27. Then we can scroll in either direction very easily and just reset back to 0, 0. So that's the goal there. Let's change this back to 9 and back to simple. So what are we gonna do here? Sprite renderer dot size. I need to set size. Okay. Size is going to be equal to we want to do. Actually, what we want to do is just take our current size and multiply the whole thing by 3. So we don't want the y to change any, so we're going to multiply that way 1, but we want the x value to be 3 times its current size. So if we come back, save this, and come back to Unity and hit play, when we hit play, this should actually tile out and be that 3 sized width. And it is not. Why is it? Upset. Let's make sure that it's actually calling this. Okay. Oh, the script isn't on there. Okay, well, that'll do it. Okay, so now that the script's attached on there, if I start it, it should be, there we go, 3 times the size. Now it has this little complaint here that the mesh type on the sprite is not set to full rect. So let's close this down, go to the sprites, and click on our sprite here, and change the mesh type from tight to full rect, and hit apply. Now if we play the scene again, it should do the same thing, but not have that error. Okay, that's good. So the next thing that we want to do is we've got our background, we've resized it so it's big enough to do the scrolling. Now we just need to give it some kind of speed. So we want this to be configurable in the editor. So we'll create a private float for scroll speed here. And we'll set this to, I don't know, 1 by default. Then in our update function, we can take the transform position and multiply it by a new vector 3 that is the scroll speed times time.delta time that's not what we want to do. Yeah, we do. So that I'm going to move this much. Yeah, we want to not multiply. We actually want to add. We want to add this distance, our scroll speed times our delta time. So we move nice and smoothly. And then actually, let's just store this in our position is equal. Transform position plus this movement. Okay. Then you should see if we go back here and hit play, it should start scrolling. Nope. It's probably because the scroll speed is 1. See what's going on. Oh yeah, it's because we haven't actually set the transform position. Back here. Hit play, resizes the background, and now we can see down here it starts scrolling. We can see it nice and clean down there. But it's going to get to the edge, and that's that. What we want it to do is reset itself back to where it originally started. So to do that, we need to figure out what the actual width of our texture is and figure out when it's moved that distance. So we need to store this value. And then we can get the texture width from the sprite renderer. And that's just going to be the X size of our sprite. But we need to do it before we resize it. We want it to move. See when it's moved one whole width, not the bigger 3 by width. So to do that, we will get the sprite renderer, the size of it, and the X value is the width of it. Get rid of some of this white space here. Then what we can do is down here, if we've moved in either direction by the texture width amount, and so to do that, we want to be able to compare if it's going in the negative direction or the positive direction. And to do that, to normalize that, we call the absolute value function, which just takes, if it's positive value, it'll return the same value. If it's negative, it'll return the positive of it. So like if it's -3, it'll return 3. If it's 3, it'll return 3. So we've moved this many actual units. And if that's greater than or equal to the texture width, then we just want to set the position of our image's X value back to 0. Okay, so now we're scrolling. And when it gets to the edge here, you should notice that this jumps back to the middle, but down here, it just looks like it's seamlessly scrolling. Great. That's our scrolling background. So now, in order to get any kind of background or get any kind of infinitely scrolling object onto the screen, we just put the object in the scene, put the script on it, and we're good to go. So that background speed is actually a little bit fast, so I'm going to choose 0.5 for it. And now this should be a nice, slow scrolling background, which is great. Because it's further into the distance, so we want it to scroll slower than stuff that's in the foreground. So now with that in place, we can go ahead and add these changes in and commit. And push up our changes. Great. So now that we've got an infinite background, we want to do the same thing, but with just the normal ground, the foreground. So we'll come to our sprites here. We'll find the ground element and drag that onto the scene. And then we're going to reposition it so that it's down at the bottom. Okay. And rename this to ground. And we want this to be on a different sorting layer so that it's always in front of the background. So they're both on 0 right now, so this we'll want to set to 1. And now we want to attach the horizontal scroller to that ground. And it's fine, we can leave this at 1 for now. And go ahead and hit play, and we should have both of these scrolling but at different speeds. So yeah, our foreground scrolls faster than the background. Pretty neat. And then they both should do the wraparound, yep. And they'll just keep doing that. And now this gives the impression that we're moving forward in a scene. Or actually, this would be moving backwards. So actually, we want to make these scrolls in the negative direction. Now, it should be going across this way. So yeah, now it looks like we're going forward in the scene instead of backwards. Okay. Pretty good. Well, let's just go ahead and make sure that that actually does what it's supposed to do there. Looks good. Okay. So we've got our ground, and the next thing that we want to do is actually add a box collider to the ground, because when we bring our player on shortly, we are going to want to have something happen when the player runs into the ground. So we'll add a box collider to the ground, and that should be good. It should automatically outline the ground. That in place, we can go ahead and commit these changes. All right, next thing we want to do is get our player into the scene and moving around. So let's go to our sprites here and scroll down until we find our little bird guy. Drag him into the scene. Bring him down just a little bit. Starting out right about there. And change the name to player and the tag to player. Then we're going to set the order layer to this to the same as our ground. Set that to 1. And that is our player in the scene. Next thing we want to do is actually add an animation to our player. Just want to have him flapping the whole time. So we're going to go here, open up the animation window, and dock this to our editor, and go ahead and create a clip. Now we're going to put this clip inside an animations folder. Save that as bird flap. So now to make the animation itself, we're going to drag our 3 bird elements onto the timeline. And if we were to play that, it would be, whoa, super duper fast. So what we actually want to do is slow this down. And we do that with the sample rate. So instead of basically 60 frames a second animation there, we're going to change this to, I don't know, 16. Oh, didn't save it. There we go. Now it's a nice, gentler flap there. All right, that is our dude, our little bird in the scene and animating. Next thing we want to have it do, though, is respond to our input so that we can bounce him up and down like you do in Flappy Bird. So to do that, we are actually going to create another script for the player. Drag that onto the player object. Script on there. Now we can open up this script. And drop this stuff out. Now, before we continue, we actually want to put a few components onto our player so that we can control its movement, or the physics of its movement, as well as when it interacts with other things in the scene. So to do that, we will need a rigid body 2D. And we're actually, yeah, this is fine. We want to simulate gravity here. And the other thing that we want to do is add a box, or not a box collider, a circle collider, because our player is actually very circular. So if we scroll in here, we actually want to just bring the radius down just a little bit there. That looks pretty good. So when our player bumps into stuff, this circle anyway runs into anything else that's collidable, we'll get some sort of triggered event when that happens. And then we can react to it. Like if it runs into the ground, we want to, into the game. And if it passes through the goal point, we want to increase the score, that type of thing. So, all right. We've got our circle collider and that. Go ahead and open the script. And so what we want to do is whenever a button like the space button or whatever's been assigned to the flap action, or as Unity has it, it's a jump. If we look at the Unity project settings in the input manager, Unity has a bunch of already preset actions, and one of them is jump. So we can just reuse that action. So in the update, if the player has pressed down the jump, we want to do something. But what do we want to do? We actually want to add a force to the player that lifts it up. So we do that via the rigid body. And so in order to work with the rigid body, we're going to need a handle to it. So let's create that. And then in our wake function, grab a handle to the rigid body. So now we've got a handle to the rigid body and we can do stuff with it. So what we want to do is actually apply an upward force to it. And that force we want to be able to control via the editor so we can tweak it while we are playing the game and whatnot to find what works best. So we're actually going to create a serialized field. Let's just call it the flap force. How much upward force we get. So now to apply that force to our player, we use the rigid body. We add a force, and we want it to be a straight upwards force. So we'll take the vector 2 up identity, vector 2 up, and multiply that by the flap force. And that should be it, really. So we'll come back to our scene here. Just a little bit, and then on our player, we should be able to set the flap force of this guy to something like, I don't know, 3. Let's see how that works. Doing anything. Oh, good. So should be fine. Make sure, yeah. Player has that on there. And the space should be the button for the jump. Let's go to the project settings here and jump. Yep, it's the space button. Out of this. Start the scene again. That's not good. Let's figure out what's going wrong there. So first thing we want to do is do a little debug log. Jump pressed. Just make sure that our player is doing the jump when we press it. Yep. That's fine. Interesting. Got our rigid body. Got our circle collider. We've got a rigid body with the gravity scale. Want to freeze the rotation on the axis. Set a flap force. Maybe the flap force needs to be higher. You'd think it would move some though. think the problem is the force is still not big enough. Let's try something like 300. There we go. Yeah, it just wasn't applying enough force. So that's good. Okay, got our bird and our guy, and he's flapping along. Okay. Now the next thing is, if our player hits that ground, we actually want to stop the scene, and we'll just go ahead and restart the scene for now. So to do that, we can check via the on collision, enter 2D, and if we've collided with anything at all, we actually want to just restart the scene. So to do that, we use the scene manager, load scene, and then we want to use the scene manager active scene, get active scene, and the ID name. I think maybe. Here. Play it. Now when we run down or hit the ground, it should just restart the scene. Oh, nope, it sure didn't do that. Oh, but it can't. Template string, valid build index. Let's make sure. Build settings. Gameplay. Oh, okay. So over here, we actually want to use our build index. There we go. So when he falls down and hits it, oh, restarts the scene. Cool. Okay, that's that. I think that is a good place to commit our player. So with our changes, we'll add them and add flapping player bird and push those changes up. Okay. Now we're ready to build the pipe obstacles that's part of Flappy Bird. So that's actually made up of 2 pipes, one for the top, one for the bottom. So I'm actually going to come over here and create an empty object called obstacle. I'm going to drag this off the right hand side of the screen here. Somewhere about there is pretty good. And then I want to add 2 pipe objects. The top pipe and the bottom pipe. Actually, and we'll set this to reset this. There we go. There we go. Okay, so now we're going to call this one the top pipe, and we're going to put this one at, I don't know, 3. Bottom pipe, and put this one at -3. That's 6, 10, yeah. Is that -10? Oh, that's a big opening there. So let's try maybe 5. No, maybe 7. 7. Yeah, that looks pretty good. So this will be our obstacle. Oh, okay. So we actually want box colliders on each of these. So if the player runs into them, it'll do the same effect of having it start over. So we want box collider 2D and a box collider 2D. Looks pretty good there. What else do we want here? Actually, what do we want here? We need one more thing. We need some way to trigger when the player has gone through the pipes so that we can register a score for him. So let's actually, in the obstacle itself, create a box collider 2D. And then what we'll do is change it so that it's there. We actually want this, we don't want this to be something that the player collides with. We actually want it to be a trigger. So it can still fly through it, but we can still get notified when that happens. Now we're going to add some customization to the pipe so that it can just flow across the screen here. Now, to do that, we will create a script, call it obstacle. Let Unity think for a second, and then drag this onto our obstacle object. Now, with that in place, we'll go ahead and open up the obstacle script. For a second. Okay, get rid of the unnecessary stuff here. Now we're ready to start working with our obstacle. So this is similar to the scrolling. We're going to have some horizontal X speed that we want it to scroll, and then we'll just update its position of the object each time. So we need, first thing we're going to need is a speed. Just set this to 1 by default. And then in our update, we can take the transform position and add a leftward motion, left, by the speed and time.delta time, so it happens nice and smoothly. Oh, the speed actually goes inside the class, not outside of it. Okay. So now when we come back over here to Unity and we hit play, we should see that pipe moving across the screen. Well, it's moving, but we don't actually see it. So in order to fix that, what we want to do is come over here to our sprites and change these to actually be behind the foreground and in front of the background. So to do that, we'll set these to 1s. We want the player on that same order layer, but now we want the ground itself to be on 2 in front of the player and that. So okay, now when we hit play, we should see the pipes scrolling across. It looks good. There we go. Now when we run into the pipe, it starts over. That's what we wanted to do as well. And then when we fly through it, it's going to not really do anything right now because we haven't set up anything to react to it. So let's actually go ahead and do that. If we go over to our player script, and look for the on trigger enter 2D. Trigger enter 2D. What we want to do is increase a score. So right now we'll just go ahead and create a private int for the score. and then when we trigger it here, we'll just increase the score, and then we'll log the message for now, since we don't have any sort of interface yet to display the score on the screen. Debug log score. And C#'s nice little inline variable printing there. And we'll get rid of that exception from being thrown. So now we'll come back over here, hit play, and then when we fly through, we should see the score appear down here. Now we've got a score of 1. Cool. So, I think that's good for now. We've got our obstacle, we've got our player interacting with the obstacle. So now what we want is more of these obstacles to be generated. And to do that, we want to create a prefab, or a template basically, out of our existing obstacle. So we'll create a prefabs folder, drag the obstacle into it, and then we can delete this obstacle from the scene. And we'll go ahead and commit this for now. Add, hit commit, added obstacle checked. Cool. The next thing we want to do then is to create some sort of object to spawn the obstacle. So we'll create an obstacle spawner. I'm going to drag this off to the right hand side again, where we want the obstacles to start. And 7 seems like a nice round number. And go ahead. Actually, we'll just go ahead and reset this and set it to 7. There we go. So now our obstacle spawner is positioned where we want it to. Now, for it to actually spawn anything, we'll need to create a script for it. And then let Unity do its thing, and we'll drag the obstacle spawner onto that object. Okay. Now over here, we should be able to open this up, do this usual cleaning out of things we don't need. Now let's think about what we actually need to spawn obstacles in the scene. The first thing that we're going to need is the prefab itself. So what we do is get ourselves a handle to these, and we actually want to set this via the editor. So have the obstacle prefab. We need some interval at which to spawn the different things, and we want to be able to configure that as well. So we'll use a float to store the spawn interval. And then the height of the prefab, of the obstacle in the scene. So we want to be able to do something like this. Change the height for each one of these obstacles that get spawned. So delete that out of the scene. Don't need that. So we need a okay. Now let's go ahead and just start spawning a bunch of these. So to do that, we actually want to create what's called a coroutine, which is just a function that's going to call periodically until it's done. But in this case, we don't ever want to be done with spawning spawn for coroutine. We don't want it to ever stop spawning. So we're going to use an infinite loop here, which is just forever basically. And then we want to spawn an object, which we will create that function in just a moment. And then we want to, after we spawn, we want to yield, or basically tell Unity that, hey, we're done doing anything until the next time we want to spawn something. So want to return a new wait for seconds. And we want to wait a spawn interval number of seconds. So, okay. We actually want to start this coroutine whenever our scene starts up. So we'll call the spawn coroutine whenever our scene starts. So okay, now we've got I want to spawn. Veto. There we go. Headers here. There we go. Okay, so now when our scene starts, the object spawner is going to say, hey, start spawning things every this many seconds, just forever. So what it's going to do is actually we want to obstacle instantiate the obstacle prefab there. And then we want to update the position of this obstacle. So we want to change the height of it. We want it to actually spawn wherever our current object's position is. But then we also want to change the height on it. So we're going to give it a new vector 3 here. And we don't want to change anything in the X position, but we do want to set a random height for it between positive and negative height. So, okay. We come back over to our scene now, and we come to our object spawner. We want it to spawn every 5 seconds. Every 3 seconds, and then go 3 units up, 4 units up, 4 units up, 4 units down. That seems pretty good. Now if we hit play, we've got random does not have. I think it's just missing something here. Yeah, we want to use the Unity engine version of random, not the built-in random. So we can use the range function. Okay, that should, there we go. Compiler error gone. Now we should be able to play the scene, and the object spawner is going to start spawning objects, maybe? Nope. Is null. Okay, so I didn't actually set which obstacle that it, or what object it should be creating. So I'm going to take the prefab and drag it in over here. Now, when it starts, it should be, there we go. There's a pipe. And then 3 seconds later, there's another pipe. It's probably too quick. So let's go, I don't know, maybe 7 seconds. And 7 seconds later, it's going to spawn another one. Oh, it'd help if I was actually decent at my own game, right? Well, I guess it's someone else's game, but the game that I'm creating. But now you can see it's just generating a bunch of pipes. And that itself is going to be a problem, because once we've generated this pipe obstacle, it's just hanging around forever, even after it goes off the screen. So what we actually want to do is when it does go off the screen, we want to make that pipe disappear. So that's the next thing that we're going to tackle here. So let add it. Obstacle spawner. Okay, now that we've got that working, what we actually want to do is create just a handful of these pipes instead of creating one and then deleting it and creating another one, deleting it, creating and deleting. That could take up a lot of resources. In this game, it's not going to be noticeable. But a good practice to get into when that type of situation occurs is to create what's called an object pool. And Unity supports these by default inside of Unity now. It provides tools for object pooling, which is just to create a few objects and then reuse them as needed. So what we'll do is have the spawner create a pool of obstacles as it needs them, and then get an obstacle out of the pool, enable it so we can see it in the screen, and then set its height and send it off. And then we want to trigger when it's come off the edge of the screen here for that object to be disabled, not active in the scene, so that when the spawner goes to create a new obstacle, it can reach into its pool, grab one that's not enabled currently, pull it out, enable it, send it across. So to do that, we actually need a few things. So the first thing that we're going to do is create an empty object here and despawn point. And this is where it's going to despawn. So we'll set this to, I guess, -15 is just fine. When the pipe runs into this area, it's going to despawn. So to do that, we need to actually create something for it to run into. And the size, we want it to be pretty big. 16, the size of our screen. And then we want this to be a trigger. Okay. That should be good. So now we're going to come back to our script, and we're actually going to create an object pool. So we need to store an object pool, and that'll pull in our Unity header there. And it's a pool of obstacles. So obstacle pool. Okay, so in order to use the obstacle pool, basically down here, and when we go to spawn something, instead of instantiating it directly, we're going to call the pool and say, hey pool, I want to get one of your obstacles. And you can see that just kind of works. Now we actually have to create the obstacle pool in order to be able to use it. So let's create a new obstacle pool. It's actually a new object pool that's of type obstacle. Now it takes a number of parameters. Go over here and there. See that it takes a number of different things. What it needs to do when it creates a new object, when we get an object, if it needs to do anything special, when we release it, if it needs to do anything special, or if we destroy it, what it needs to do. So, all right, let's start by creating some lambdas here. And the first lambda is just going to instantiate the obstacle prefab. The second one is going to actually take the obstacle, and then we want to set the active state of the game object to true whenever we get this guy, so it starts drawing it. Likewise, whenever we return an object to the pool, an obstacle back to the pool, obstacle, we want to set it to not be active anymore, so it's not drawn. And finally, if the object pool creates too many of these guys and it doesn't need them anymore, then we want it to destroy the obstacle. Abstract obstacle. Obstacle. The game object. And then it's got a few more parameters here, and we'll just go ahead and set this to false and 10 and 20. It's probably not going to ever need that many, but hey, that's fine. So we have a way for the obstacle to spawn these guys, but now we need to trigger whenever the obstacle is actually run into it to release itself from the pool. So to do that, we're actually going to need on our obstacle a handle to the object pool. Object pool, obstacle pool, and then we will create a public setter, set pool, and then whenever this guy triggers, that runs into the trigger that we created, we actually want it to release itself. So first thing we want to do is we need some way to identify this despawn point as the actual despawn point. So we will use the respawn tag, since this is a respawn trigger basically. So whenever our obstacle runs into the specific respawn trigger here, then we'll do something. So all right, so on trigger, enter 2D here. If the thing we collided has the respawn tag, then we want to call the obstacle pool and release this particular object. And that, I think, should be pretty good. We've created our object pool. And then we're actually getting our obstacle object and then updating its position. So that should be good. And then once the obstacle itself runs into the respawn trigger, it's going to release itself. So it should stop drawing. So now if we come back here, we don't have any errors, it looks like. So we'll try this out. Got our player. Now when it goes off the screen, and it's not. And I think I know why, and it's because we need both the obstacle to have a rigid body 2D. I want this to not respond to gravity, so we just want this guy to be static. I think we're still going to have a problem because I think the despawn point needs to actually have a rigid body as well. But let's test this out. Whoop. Here, and it doesn't look like it's going to. So okay, let's come out of here and give our rigid body 2D, and this is also going to be a static. Now that should trigger when it runs into this. It's not, so let's pause that. On trigger, let's see. This is a trigger. The despawn point is a trigger, and the despawn point is a respawn element. Okay. So let's see. Good old debug log. Despawn obstacle. Okay, try this again. See if that event gets triggered. Oh, I think I know why it's not. That event is going to have got triggered, but I don't think I actually passed the object pool to the obstacle. How's this? Nope, doesn't appear to have triggered. Is anything triggering on the obstacle? I think, oh, maybe it needs to be kinematic. Probably gonna have to change that back. Kinematic. Despawn point is also kinematic. And then in our script here, I actually need to call this set pool from where it created this. So our obstacle, then obstacle set pool, obstacle pool, and then we need to return the obstacle. Okay. So that should be good. Now, obstacle entered trigger. Okay, pull up the Unity editor here and make sure that this is working. Does something. There we go. Now those pipes, once it gets so far off the screen, it will despawn. And we're counting up our scores, so that's great. Go ahead and get rid of this debug log. That looks pretty good. And then while we're here, a few things. And go ahead and cache this transform position. Actually, I don't think that's really necessary. But this guy, we're creating a wait for seconds every time we spawn something, but we don't actually have to do that. We can reuse the same instance of wait for seconds. So we'll actually create a private wait for seconds up here. And then create that guy. New wait for seconds there. And then use it. Cool. All right, that's our obstacle spawner. Looking pretty good. Now we'll go ahead and actually, before committing that, since I made a code change, just test this one more time to make sure that it's doing what it's supposed to do. There we go. Oh, that's one of the tough ones. Oh, yeah. Probably should have made those a little easier for the development mode here. All right, so that's working. Will we disappear? Yep, looks good. All right, so that's basically the core mechanics of the game. You can see the score, the pipes are getting created, we're able to flap and fly around them. It restarts whenever we run into something, and the score actually restarted. That's a weirdness there. I haven't figured that one out. It's kind of a bug. I'll probably fix that one on a future stream, but by default, it'll just restart. Every once in a while, though, it kind of seems to slip through the cracks. So figure out what's going on there. Let's see. So we've got our spawner, pools. That's pretty much it. So we can add our changes here. Reuse obstacles. And then obstacle spawner. All right, looking pretty good. So the next thing we actually want to do is show our score on the screen. And then after that, we want a game over screen that we can restart the game with. So let's start with the player score. We'll do that by creating a Text Mesh Pro text element. Scroll out so we can see here. We need to import the Text Mesh Pro essentials. Using Text Mesh Pro because it does a better job of showing pixelated text, I think. So we'll pull this in the middle here. Actually center, vertically center. I don't know. 0. We want the default text to be 0. Now, in order to get it into that's fine as it is, but we actually want it to show a different font. and we'll rename this to score. So in order to display a different font, we'll create a folder for fonts and come to our assets. Flappy Bird, grab this font, drag it in there. We still can't use it directly on a TextMesh Pro font. We can't just drag this font over there. It doesn't like that. It wants a special TextMesh Pro font asset. So to do that's pretty easy. We just right click on a normal font and go down to TextMesh Pro and create a font asset. So now when we come back to the score, we can drag this on there, and now we've got a nice little deal. But it kind of fades into the background there. So to make it punch just a little bit, we want to give it an outline. I don't know, 0.15. That looks good. So now it's got a little outline on it, and that's great. But now the challenge is to get the score to reflect the same score that's on the player. And the way that I'm going to do that, solve this particular problem, is actually create a scriptable object which can store data and be referenced by multiple objects in the scene. The other benefit is that it will hold its values from one play session to the next. So it might be a good place if I want to add, say, a high score feature down the road. But for now, what I'll do is create a C# script and call this game data. Writer doesn't seem to pick this stuff up until I actually switch over to it, so I can't just double click on a script that I've created and have it open. So, but I need to delete this stuff out because we're not actually going to inherit from mono behavior. We're gonna inherit from scriptable object, and all scriptable objects need to have a special tag put on them so that when we come over here, we can create our game data. But let's go ahead and actually store a public int score. It's good. That's what we need. So what we'll do is actually create an asset, a folder called data. In this case, in Flappy Bird, we're just going to have one critical piece of data, which is the score. But in other games, you might have more data that you're tracking, like health bars or mana bars or mana bars, however you want to pronounce that. But in this case, we just have the one thing. But it's still a nice technique for referencing game data from multiple different things without having to create singleton objects that get accessed all over the place. Let's see, let's just call this game data. Now that we have this game data that holds the score, we need to reference it from both the player and the score. So let's start with the player. And instead of a score here, we're going to create a serialized field for the game data. Then instead of our internal private score variable, we'll use this. Okay, that's looking good so far. If we come back over here, we should be able to play the game and actually not see anything change. It should still keep a score, and the score should show up down here at the bottom. Oh, and it's not, because I didn't actually drag the game data onto the player script, so it doesn't know where that is. So now, okay, do this again. keep an eye on our score there, we'll see it increase. And it did. There, it now says 1. But if we die, we'll notice that it still says 1. Like I said, it carries over between scenes. So we actually need to, when the player starts the scene, reset our score. So let's create a start and game data score, set this to 0. So now we'll come back here, play the game, and earn a point, maybe. Earned a point. Now if I run into something, it'll actually reset to 0. That's what we want. Okay. Now we've got the player tracking the score in this central game data. Now we need this score element to update. So what I'll do is on the canvas, I'm going to create a C# script and just call this the UI manager. Or actually, since this isn't very, it's just going to track the score, we'll rename it to Score UI. You see, if I rename it, it actually doesn't rename the class name in the file. So I need to come over here and change this to Score UI. Now I can come back over to Unity and drag this onto the canvas. Okay. Now that that's there, can go back to it and get rid of this stuff that's not needed. And we're gonna get an instance of serialized field. We're gonna get that game data instance. And then we also need to access the text mesh pro field. So we'll tm text is its type, and it's our text UI. Serialize field. Oh, it doesn't like that. Okay. Okay, we've got to import its type there. Then in the update function, every update, we just want to set the text to whatever the current score is. So we'll go to the text UI, we'll set the text to the game data score, and it's currently an int, so we need to change it to a string. And that should be that. We'll come back over here to Unity, and our canvas now needs to reference the score text and also the game data. And then when we play, this should now reflect our current score. And it does. And then when we crash land, it should reset to 0, and it does. So cool, that's the score. And with that in place, we can actually go back to our player and remove this debug log so that it's not showing up all the time. I think that's our only debug message currently. Yep, go ahead and close out of some of these scripts here. Cool, that's our player. We've got obstacles spawning, despawning. Our player can go through them. We can track a score. Now we just need to have a more user-friendly way of restarting the scene when it happens. Instead of just immediately restarting, we want to pause and reflect on how well we've done and then opt into restarting when we're ready. So to do that, let's first we're at a good stopping point. Let's add our changes and add a UI score. Push those changes up. let's see. Now we want to create a new canvas that we can actually turn on and off when we want it to. So I'm going to create a new UI canvas, and we'll call this the game over screen. Okay. Now we want to add a few things to this. We want to add a UI, an image, and we want this image to be the name of the game, Flappy Bird, and it's got some wonky dimensions. What are the dimensions of this sprite? Easier if I go in here, or the Sprite Editor, go to Flappy Bird, and it is 89 by 24. So let's try that. 89 by 24. Then we can scale it up as needed. There we go. We want it to stay proportionally big. So there we go, Flappy Bird. And then we want to move this guy up towards the top here. And then we want our game over, and that's going to be another image. So let's see, game title. And add another image here. This is the game over text. Sprite in there, and what are its dimensions? Game over 96 by 21. 6 by 21. And we want to scale it proportionally. Scale this up quite a bit. Let us know. Yeah, it's definitely a game over, man. Game over. All right, pull that up there. And then the last thing that we need, some kind of button for the user to interact with. So we'll just go ahead and grab one of these Text Mesh Pro buttons. We see it's got a child and it's got some text, but we don't actually want that. We're just going to use an image, so we can delete that. And this is our restart button. Restart. And then the sprite that we want to use is not the default UI sprite here. We want to use this guy. And same kind of deal. We will see what its default dimensions are, and that's 52 by 29. We'll go 52 by 29, and we'll scale this up just a little bit. And this one we're going to bring down. There we go. Way between the ground. Well, I guess the players can be anywhere here, so we'll just do that somewhere right around there. That way, if the player is touching the ground, the respawn button will not be over them. Or actually, let's go ahead and pull it here. That looks good. I like that. Okay, so we've got our screen here, we've got the elements of it, but we need it to actually, do stuff. So we have to, anytime we need to add custom functionality to something, we need to create a script. So let's go to the script folders and create a new C# script for, I don't know, let's call it a game manager. We're actually going to create an empty object called game manager and pull this onto it. So we've got something in the scene that's our game manager. Right, got that, and we can open up our game manager, get rid of the usual stuff, probably do a video soon, and set up my environment to have this default thing automatically not include the extra stuff in it. But for now, go ahead and continue on and think about what this game manager needs to do. So when the game hits the game over, we actually want everything in the background to stop doing anything. And in order to do that, we can use a built-in Unity function to actually stop time. Pretty cool being able to control time. But for now, let's think about what we need. A game over. We need to tell the game manager the game is over, and then we need to tell it to restart. Really the two main things that the game manager is going to be responsible for. Game over and restart. So let's create some public game over function and then a public void restart function. So in the game over, like I said, we're going to need a handle to the canvas so we can tell the canvas to draw itself. So serialized field, private game object, the game over canvas. And when the game is over, we want to tell the game over canvas to be active. The other thing we want to do is to set the time scale equal to 0 so that it stops. Which means that when the game starts, we also want to make sure that we set the time scale, even though it's default set to 1. When we actually restart the game, it'll be set to 0. We don't want that. We want it to start up again, start playing at the normal speed. So the last thing that we need to do is to restart the scene, which we have actually already done in our player script. If we come over here on the collision enter 2D, we've loaded up the screen. So what I'll do is actually create a serialized field here for the game manager. And instead of calling this directly, we will just call the game manager game over. And we can copy this out of here, come back to the game manager and restart it. Now we need to include the missing references, so done that. That's good. Okay, so now when the player runs into something, instead of restarting the scene, it's just going to tell the game manager, hey, game's over. I ran into something. Now we need to have this button here hook up to the restart. So that's actually pretty easy now. We've got a restart method that will just restart the scene right here. So in Unity, we can come to the restart here, and when it's clicked, we want to do something. So we'll drag the game manager, and we will call the restart method on the game manager. The last thing we want to do is this game over screen. We don't want it to be showing by default. The game over function is actually going to set it to be enabled, but by default we want this guy to be off. So okay, now when we play our scene, we should, oh, we've got a null reference. What's reference? Oh, our player. I bet I did not set the game over or the game manager on the player script. And no, I did not. So I need to drag the game manager onto the player. Now, when I play, it should not have any problems. So playing along, flying along, we got a score, and then oops. Not what we want. The variable game over canvas. Oh, the game manager needs some stuff set on it. So, okay, let's look at that. Yep, sure enough, the game over screen is not set on it. Okay. Now let's play it one more time. flapping along on the Flappy Bird. Bird is the word. Okay, got one, and then what is going on there? Oh, it's still that bug of sometimes we fall through the floor. But now the game's over, and if I hit this button, it should restart, and it does. Score. Run into the pipe. Oh, game over. Restart. So that's pretty much it. A couple things that might want to do to enhance the game some, such as figure out this bug when we hit the ground sometimes. Sometimes it doesn't, it's not a problem, but sometimes it is. Sometimes we fall through the cracks. We'll have to figure that one out. That's a one I don't know off the top of my head. But we basically have a complete Flappy Bird game. We can flap our bird, we can fly through pipes, the pipes get created at random. We can track our score, and then we have a game over screen that we can use to restart the game with. So, pretty cool. That's quite a bit accomplished for not a whole lot of time, really. Thanks everyone. It's been fun building out a game pretty much from start to finish on this stream. And if there's any questions, comment below. Next week I'm going to be doing another stream where I look at cleaning up some of the code, maybe add a start screen, maybe add a high score, and fix any bugs that I've come across, like the weird ground issue. But other than that, we've got a complete functioning game. So thanks everyone for watching, and I'll see you next time.